Okay, this is practice 7.2, form G. This was the second page in our packet. Questions 1, 2, and 3 here want us to list the pairs of congruent angles and write the extended proportion that relates to the corresponding sides for the similar polygons. Okay, so we know two things about similar figures. Their angles are congruent and their sides are proportional. So angles are congruent, we can get that from our similarity statement. So angle A is going to be congruent to angle W. Angle B is going to be congruent to angle X. Angle C is going to be congruent to angle Y. So B and X, C and Y. Okay, and then angle D is congruent to angle Z. So if these figures are similar, they're the same shape, different sizes. They're the same shape because their angles are all congruent. The corresponding angles are congruent. So there's 4 corresponding angles: A and W, B and X, C and Y, and D and Z. Okay, now we need to write the extended proportion that relates to the corresponding sides. So we just pick a side, AB. AB corresponds with, you can either use the diagram between the 1 arc and the 2 arc. So AB corresponds with WX. Okay, the other way you can do it is look at your similarity statement. AB corresponds with WX. Okay, so that's the first ratio of corresponding sides. The next one, BC. So BC is between the 2 and the 3. That's going to relate to X and Y. Okay. CD is going to match up with YZ. Okay, and then AD is going to match up with WZ. Okay, if your numerator comes from the first figure, it needs to come from that figure for each time, right? All 4 of these are the 4 sides of the first figure, and the denominators are all coming from the second figure. Okay, and then they match up. AB with WX, BC with XY, CD with YZ, and AD with W. Okay, let's do 2 and 3. Okay, triangle MNO and triangle RST. So we know angle M is congruent to angle R. Okay, you can't really tell on this one, so you have to use the similarity statement. M is with R, N is with S. And then angle O is congruent to angle T. Those are your congruent angles. And now we need to write the extended proportion. So MN, of course, is between the 1 and the 2 arcs. Okay, that's going to correspond with RS. So MN and RS. Okay, NO and ST. And then MO with RT. In here you want to use your similarity statement. It really helps to look at the similarity statement. So angle N is congruent to angle T. Okay. First letter in each one. P with Q. Okay. O with R. And then M with S. And then we got to write our extended proportion. So NP corresponds with TQ. Okay, you can look at the similarity statement. NP is the first 2 letters, so TQ is the first 2 letters. Or you can look at the arcs we just put in. So NP is between the 1 and the 2. TQ is between the 1 and the 2. So NP corresponds with TQ. Okay, and then we just can go around. So PO matches up with QR. Okay, OM matches up with RS, and then NM matches up with TS. Okay. So basically this has been rotated, or you can think of this one as needs to rotate 90 degrees this way to match up with this one. Okay, angles are congruent, sides are proportional. So the ratios are equal. The ratios of the corresponding sides are equal. Okay, 4, 5, and 6. We need to determine if the polygons are similar. If so, we want to write a similarity statement and give the scale factor. Okay. So for these to be similar, you need two things. You need angles to be congruent and sides to be proportional. So here we have, we can think of this as being rotated again. So P matches up with R, M with S, N with T, and O with U. So we have 4 pairs of congruent angles, so we're good. Okay, so angles are good. Now we need to check sides. Sides are proportional. Well, we can write those all out, right? So angle P is congruent to angle R, M with S, N with T, and then O with U. Okay, so angles are congruent. 4 pair of congruent angles. Corresponding angles are congruent. We're good. Now sides are proportional is the next thing we have to check. And that means that the ratios of the corresponding sides have to be equal. So let's do our ratio. So 3 here is going to match up with 4.5. 3 is going to match up with 4.5. 3 with 4.5, and 3 with 4.5. So all of our ratios are 3 over 4.5. If we put that in the calculator, 3 divided by 4.5, we're going to get 2/3 each time. So 2 over 3 equals 2 over 3 equals 2 over 3 equals 2 over 3. So we have 2/3 over and over again. So all those ratios are equal. Therefore, the sides are proportional. And since the sides are proportional, we know the figures are similar. So we're going to say yes. Okay. Our scale factor is the ratios we got, which were 2/3. So our scale factor is 2/3, or 3 over 2. Okay. And then we want a similarity statement. So how about P, M, and O is similar to R, S, T, U. Again, the first one can be in any order. As long as you're going clockwise or counterclockwise, starting from one of the points, one of the vertices. But then you got to match up the corresponding points on the other ones. So P can match with R, M with S, N with T, and O with U. Okay. Number 5 here. We already have a problem because you have 4 right angles on one side. Now this one we don't. So since the angles are not all congruent, we would say that they're not similar. Angles need to be congruent. So this one, angles not congruent. The angles are not congruent. Okay, this one we have 2 right angles. We don't know about K and E and L and F. They may or may not be congruent. So based on just the angles, we can't really say. But we can certainly check the sides to see if it's going to work out. So 2.5 is going to match up with 2.5. Okay, 6.4 with 9.6. 3 is going to match up with 3. And then 6 with 9. Okay, 2.5 divided by 2.5 is 1. 6.4 divided by 9.6 is 2/3. 3 over 3 is 1, and then 6 over 9 is 2/3. So these are in fact not equal. Therefore, our ratios are not equal. Since our ratios are not equal, the sides are not proportional. And if the sides are not proportional, then our figures are not similar. So we would say no, sides are not proportional. Okay, 7, 8, 9, and 10 here. So we want to determine if they are similar. These polygons are similar. An equilateral triangle with side lengths 6 and an equilateral triangle with side lengths 15. Okay, we know equilateral triangles have 3 pairs of congruent sides. Or just 3 congruent sides. I'm sorry, not 3 pairs, just 3 congruent sides. And we know the angles of a equilateral triangle are all equal, so they're 60, 60, and 60. So we know the angles here are 60, 60, 60, and 60, 60, 60. So we have 3 pairs of congruent angles, so our angles are congruent. Now we need to see if our sides are proportional. So our ratios would be 6 over 15, 6 over 15, and 6 over 15. So yeah, the ratios of the corresponding sides are all equal. They're all 2 over 5, right? 6 divided by 15 will be 2/5. So the sides are proportional because the ratios are equal and the angles are congruent. So yes, they are similar. Square with side lengths 4. So we know squares have right angles and the side lengths are 4. Okay, and a rectangle, we know rectangles all have right angles, and it has a width of 8 and a length of 8.5. Okay, well there's 4 pair of congruent angles there, right? 90, 90, 90, and 90. Matches up with 90, 90, 90, and 90. So the angles are congruent, but we also need the sides to be proportional. So if we set up our proportion, 4 over 8.5, 4 over 8, 4 over 8.5, and then 4 over 8. Those turn out not to be equal. So our answer here would be no, they're not similar because the sides are not proportional. Okay. The triangle with side lengths 3, 4, and 5. So if we draw a triangle, 3, 4, and 5, and then a triangle 18, 19, and 20. Let's do this. 3, 4, and 5. Okay. If these are going to be similar, the small side of one triangle is going to match up with the small side of the other. The largest side of one triangle is going to match up with the largest side of the other. And then the two that are in the middle are going to match up. So if they were to be similar, 3 would match up with 18. 4 would match up with 19. And 5 would match up with 20. But if you put these in your calculator, you're going to find that these ratios are not equal. Since the ratios are not equal, the sides are not proportional. The ratios of the corresponding sides are not equal, therefore the sides are not going to be proportional. So this one's also a no. Okay, a rhombus with side lengths 8 and consecutive angles 50 and 130. So let's draw that. We have a rhombus, 8, 8, 8, and 8. Consecutive angles are 50 and 130. So then these are also going to be 50 and 130. Okay. And a rhombus with side lengths 13. So it's a little bigger. And our sides are going to be 13, 13, 13, and 13. And consecutive angles are 50 and 130. So 50 and 130. Oh, sorry. Opposite angles are congruent. So 4 pair of congruent angles, 15, 50, 15, 50, 130 and 130, 130 and 130. That's 4 pair of congruent angles. Our sides, are the corresponding sides, are the ratios of the corresponding sides equal? Well, 8 over 13, 8 over 13, 8 over 13, and 8 over 13. Yeah, they're all going to be the same. So this one's going to be yes, yes. 8 over 13 is going to be the same ratio each time. That's the first half. Go to the second half. Okay, an architect is making a scale drawing of a building. Okay, she uses a scale of 1 inch to 15 feet. So they're giving you one of the ratios. 1 inch is 15 feet. If the building is 48 feet tall, how tall should the scale drawing be? So if it's every inch on the scale is 15 feet in real life, how many inches would a 48 foot tall building be? So you're going to have x over 48 feet. So you cross multiply, you get 15x equals 48. Then when you divide by 15, you're going to get x equals 3.2. So it's going to be 3.2 inches. So if 1 inch is 15 feet, if 1 inch is 15 feet, then 3.2 inches is going to be 48 feet. Okay, if the building is 90 feet wide, how wide should the scale drawing be? So same thing. We're going to have 1 over 15. Okay, and then how many inches is 90 feet going to look like? You cross multiply, you get 15x equals 90. Divide by 15, x is going to be 6, so that's going to be 6 inches. Okay, so 6 inches on the scale is going to be 90 feet because every inch is 15. So that was 11. Let's do 12 now. Okay, a scale building was made by a scale of 15 centimeters to 120 feet. So 15 centimeters is 120 feet. They're giving us that ratio. Every 15 centimeters is 120 feet. How tall would 45 centimeters be? Well, 45 centimeters is how many feet? 15 centimeters is 120, so 45 is how many? Okay, you could also have done 15 over 45 equals 120 over x. For this one, you could have done 1 over x is 15 over 48. 1 over x is 15 over 90. Those proportions would have worked too. But here, if we cross multiply, we're going to get 15x. Let's just go to the calculator on this one. Um, 128 times 45 is going to be 5,400. Should have had that. And then divide by 15. It's 360. So 360 feet. Okay, we're going to check our answer. 45 divided by 360. Should equal 15 divided by 120. They both are 1/8. Okay, good. Okay, determine whether the statement is always, sometimes, or never true. So 2 squares are similar. Well, the angles are going to be congruent. Okay, and then the sides are going to have to be proportional, right? If this is A, and the rest are A. If this is B, then the rest of these are B, right? Because they're squares. So your ratios would be A over B, A over B, A over B, and A over B. B in all those ratios, no matter what A or B is. A could be any number, B could be any number, but the ratios are all therefore going to be equal. So this one is always. Okay, they're always going to be similar. Okay, two hexagons. That one's going to be sometimes. You could have a regular hexagon, and you could have an irregular hexagon. Right? Those are two hexagons, they're not similar. But we could have another regular one where all the angles are the same. So, sometimes. Two similar triangles are congruent. So here you could have similar triangles. Those are not congruent because they're different sizes, but you could have them being the same, right? They could be if the scale factor here was, right, if your scale, right, 2 over 2, 2 over 2, 2 over 2, your scale factor would be 1. So if your scale factor is 1, then they're congruent. So this would be a sometimes. Okay, a rhombus has 4 sides, a pentagon has 5 sides, so this is going to be never. They don't even have the same number of sides. How could the sides possibly be proportional? They can't be. Right, 17, they tell us the polygons are similar. Okay, so we need to find the scale factor. So we first need to find y before we can find the scale factor. So it's telling us that they are similar. So AB is going to correspond to TS. So we can do 17 over 25.5. Okay, and then 3y minus 0.5 minus 3.5. AD is going to match up with TU, so that's 3y plus 6. Okay, to solve a proportion. I mean, we could write the rest, but we don't need to because they're just going to be duplicates. We have our proportion to solve for y, so we cross multiply. So 17 times 3y plus 6, and then 25.5 times 3y, times 3y minus 3.5. Okay, so this is going to be 51y plus 102 equals 25 times 3, 75, so 76.5y minus, I think it was 80 something. $89.25. Right, we've distributed our 17 and 25.25. We can then subtract 51y from both sides. Okay, so you get 102 equals 25.5. Y. And then you add 89.25 to both sides. So 191.25. Then divide by 25.5. We get y equals 7.5. Okay. So if you were to plug that in, 3 times 7.5 minus 3.5, okay, divided by 3 times 7.5 plus 6. Okay. We get 2/3. and then 17 divided by 25.5, we also are going to get 2/3. Right, so our scale factor is 2 over 3. Right, 17 divided by 20.5, 25.5 is 2/3. So if the scale factor from RSTU to VWXY is 14/3, that means this one is 14/3 the size of this one. So if you go the other way, from this one to this one's going to be 3/14 the size of this one. So that one's going to be 3/14. You're just simply going the other way. Okay, here we have triangle PRQ is similar to triangle DEF. So we know our angles are congruent, right? We know angle P is congruent to angle D. Okay, we know angle R is congruent to angle E. And we know angle Q is congruent to angle F. So since Q and F are congruent, this is 89. Since these are congruent, this is 35. We know the three angles of a triangle add up to 180, so we can do 180 minus 89 minus 35, 44. $46. $56. Right. $56. Okay, so those three angles are good. Alright, now we can set up our proportions. So we just pick a side, so how about PQ? Let's go with PR. So PR matches up with DE. Okay, you can use the similarity ratio, or you can use diagram. So PR is between 56 and 35, so between 56 and 35 over here is DE. Okay, RQ is another side. So RQ is going to match up with EF, or you can use the DE diagram, RQ and EF. I'm sorry, or the similarity statement. Okay, and then PQ matches up with DF. PQ. Okay. So then we can fill in our ratio. So I'm going to put an X and a Y on the missing ones. So I'm going to put an X here and a Y here. Okay. So PR is 40. So 40 matches up with Y. So we have 40 over Y. RQ is 36. FEF we put an X. So 46 over X. And then PQ is 20 to 24. Okay, we want to solve for X. So we're going to pick, we need to pick two ratios. Let's pick 46 over X. Okay, and then you want to pick the other one without a variable. So we don't want to pick 40 over Y because we have another variable. So let's pick 20 over 24. Okay, if you cross multiply, we get 20x. 46 times 24. It's 36. Sorry. RQ is 36. So it should be 36 times 24. 864. Okay, and then if we divide by 20, x is going to be 43.2, right? 86 divided by 2 is 43. 4 divided by 2 is 2. Okay, and then to find y, we do another set of ratios, so 40 over y. And then again, I want to pick the one that does not have a variable, so 20 over 24. Cross multiply, 20y is going to be 960. Divided by 20, y is going to be 4d8. So y is going to be 48. If we want to check our answer, we can plug them back in. 40 divided by 48. 36 divided by 43.2, and 20 divided by 20.24. If we divide all those out, we're going to end up getting 5 over 6, right? 40 divided by 48 is 5/6. Okay, 36 divided by 43.2 is 5/6, and then 5/6. So your scale factor is 5/6 or 6/5 if you went the other way. Okay, the measure of angle D was 56. Measure of angle R was 35. And the measure of angle P was 56. DE was 48. And FE was 43.2. Okay. The last one. Okay. Explain why all isosceles right triangles are similar, but not all right scaling. Not the best drawing. Okay. These are two right isosceles triangles. The three angles of a triangle add up to 180, and we know isosceles triangles have two congruent sides and also therefore two congruent bases. So these two angles are congruent, and all three angles add up to 180. So if we do 180 minus 90, we're going to get 90, and then we divide by 2, we get 45. So this would be 45 and 45. For this one, you have 90, so it's going to be the same thing. 180 minus 90. Divide by 2, so you get 45 and 45. So whenever you have right isosceles triangles, you know that the angles are always going to be 45, 45, 90. Right isosceles triangles all have 45, 45, 90 as their angles, and so those are going to be similar. Their angles are congruent. If you have right scalene, okay, you could have one that is 20 and 70, but then you could also have one that is 60 and 30. Okay, and by definition of scalene, right, the side lengths are all different. Since the side lengths are all different, the angles are going to all be different, right? Because remember, the longest side is across from the largest angle, and the smallest side is across from the smallest angle. So if all the sides are different sizes, then they're going to be across from different angle measures. So our scalene triangles are never going to be similar. There are, it says, but not all scalene right triangles are similar. There are no. Well, no, there could be. They would just be bigger. This is a counterexample, though. So you could, right? Like you could have. Well, let me draw over here a little better. You could have something like this, where it's 20, 70, and 90. And then you could have just bigger, where it's still 20, 70, and 90. But here would be a counterexample where the angles aren't all the same. But the angles have to be 45, 45, 90 for right isosceles. For right scalene, the angles could be 90 and then 1 and 89, or you could have 2 and 88, or 3 and 87, or 4 and 86, or 84 at 5.5 and 4.5. So the right scalene are not necessarily similar, but all right isosceles would be. Okay, and that is form K for 7.2, form G for 7.2.